So today we're going to talk about building timber bridges in a post-collapse environment. So what we're going to concentrate on here is disaster conditions. And what we find is the US military had a standard trestle timber bridge foundation model. And what we're going to do is look at what's called a timber bent. And that's basically the legs under the bridge. In a later discussion, we'll look at bridge abutments. There's a lot of different kinds of bridge abutments that you can build or repair under disaster conditions, depending on the soil conditions that you find beside rivers and beside low areas that you're going to have to cross. Now, what we're looking at here is Builder 1 and C. This is the CB's or Construction Battalion Training Manual. Now, what we have here is the publication number NAVPERS 10649-E. Now, what you're going to find is there's a lot of different editions of this book. And the Navy changed a lot of the construction content over the years in each edition. So what you're going to want to do is find either online or in a used bookstore all the editions, because there's a lot of difference in material and all of it is useful. So the version we're looking at today is the E, as in Edward edition. So I have several editions of this book, and a lot of construction technology has changed over the years. Some of it has stayed common. So we'll move ahead. Now, this is Chapter 8, Heavy Construction, and you can take screenshots from this video to use. You can also look this up online or get you a hard copy. Now, what I like about this CB training manual is it gives you step-by-step instructions on how to build this bridge support. Now, this is a standardized dimensional lumber. Now, you can build this out of logs. You can build this out of dimensional timber. And what you're going to find is the bottom foundation and the cap here need to be milled on two sides, and they need to be parallel. So what I'm going to suggest is that you get an Alaskan chainsaw mill, and because these lumber sizes are 12 by 12 and 12 by 14 or smaller, you can actually use the smallest size Alaskan chainsaw mill to cut these timbers. Now, I don't care how you do this in SHTF or now. If you need to get people with axes and hand hew two parallel sides, that's what you need to do. So how you do it is up to you. If you need 20 people with hatchets, you can do that too. Because what you can do is take a string line, chalk out on a log, and make one side that's flat and level. Turn the log over and hand hew the other side so it's parallel. Now, what you're going to find is these timber supports here can stay in log pattern because the flat ends are what touches. So you're just going to cut the two ends of it. If you're in a really bad situation, you can leave the bark on the logs. Now, it won't last as long if it's untreated and it has bark on the logs. So what you should expect is this will last 1 to 2 years if it's untreated. But after SHTF and in a post-collapse environment, you're going to find you're going to need to be able to get heavy equipment and trucks in and out of your area. Don't be the person that has casualties and suffers, and their community suffers because you didn't do the work. Now, what we're going to do is come over here. This is the beginning. And in the directions here, it shows you the dimensions. These are full dimensions. This is not planed lumber. So none of the sides have been planed. So when it says here that a deck is 4 by 12 inches, it's it is actually a 4 by 12 inch. So when you go to the store and you buy a 2 by 4, it's not 2 by 4 because it's been planed. This is full dimension lumber. So I'm going to give you a screenshot of this page. Now this gives you directions on how to build this. So you can blow this up if you need to. Now, the cap and sill, if you don't know the vocabulary, this is the sill board right here. This is the cap right here below the deck boards. Okay? Now, what's important is you'll notice this is perpendicular to the ground. And you'll notice these side pieces are at an angle. And it actually gives you the slope. And later on in the directions, it'll show you how to set up and use a regular square to cut these ends here so that they sit flat. And the same thing at the top. Now, one important thing about the top of this. This is 20 foot across in the area the vehicle can ride in, and then you have a 6 by 6 or an 8 by 8 curb on it. So when you calculate this out, here's the formula right here. You're going to find it's 21 foot 4 inches. So this is your formula on how to calculate the width at the top of this bridge. Now, the next page, which is page 180, will give you some screenshots of that. This is showing you how to use a regular carpenter's square to set the angles up to cut on the sloped timbers. So you can see there the measurements, how to set your square up, and you're using the markings on the square. So right here you can see the 12 marking on the square. This is a better shot. It's showing you the 1 inch and 12 inch marks. And you can set your square up, and then when you cut this, it'll give you the right angle on the bottom of the timbers so that this area sets flat and this area sets flat. So it shows you an easy way to cut those angles. So here's your screenshots. Now the next thing up is to start the initial bracing. And the bracing are these pieces here. So you'll start with a center brace that goes across here. Then you have a top and bottom angle brace. Now what you're going to want to do is alternate these. So on this trestle foundation and support, otherwise known as a bent, on this bench, you're going to have your braces running this way. On the next bent, run them the other way like this. And here's your screenshot for your directions. Now this is the only place I've really seen the how-to on how to cut these pieces and put them together. And what you're going to find is on here, you're going to have drift pins. And what a drift pin is basically a large bolt with no threads and no head. You drill the hole and you beat that down into it. Most drift pins and bolts on these military bridges and foundations are going to be 1 inch in diameter. Here, because you're using a 12 by 14, you're going to need drift bolts that are 2 to 2.5 foot long. You'll have to get a local machinist to cut those for you if you can't find them elsewhere. Now, the next thing we're going to do is look at how to build the foundation for a tower and the bents that go under it. So we'll start on page 181 with these couple sentences. Now, what we're doing here is we're building the base for a tank. And you can see it's 12 foot wide. And we'll go through this and we'll see a couple different views of what this looks like. So you'll need 2 of these for your tower. If you want to make your tower more than 12 by 12, or you're going to put something really heavy on it, you can actually have 3 or 4 of these. So here's a screenshot of the directions. This gives you your dimensional lumber. So we're using 2 by 12, 2 by 10, 8 by 12, and 8 by 8s. And then right here, we're showing you the slope of these outside legs. So you'd use your square the same way. You'd put one edge of the square on 2 and one on 12, and it would give you these angles here for you to cut. So you do that just like you would for the timber bent. Now, this is showing the tower legs from the other direction. So the last photograph, we were looking right here at the actual bottom sill going across. So now what we're doing is we're looking at a sill right here, and the sill's going in this direction. So the way this is built is you have one timber here that is perpendicular, and then you have 2 at an angle. Now, if you make this wider, you can actually put 2 or more of these on the inside if you want to make a tank platform that's bigger than 12 by 12. Now, this is 25 feet tall, okay? So these are standard military directions and designs that you can build. Now, we talked about how we're going to set this up. So this is a diagram on the top. These are how you set your carpenter square up. You can see I told you you put it on the 2-inch and the 12-inch line, and it gives you the angle to cut the faces on your timbers that are vertical. So we'll give you a good shot of the directions. And then it goes on to tell you how to actually set this up and assemble it. This shows you the legs, how they're cut off. Then when you get the legs raised, this is the order of construction. Then what you're going to do is put bracing on. More directions. And then this is the bracing. So what we're looking at here is having bracing running diagonal like this. And what you want to do is alternate that on sides to give you more stability. But there's your dimensions. It tells you exactly where to put your bracing. It gives you spacing. Gives you everything you need. So kind of in closing, this gives you an easy way using an Alaskan chainsaw mill or just using logs and locally available material to build a timber trestle road bridge. You can also build a foundation and tower for a water tower to give you pressurized water. So this is in edition E of this manual. And just so you know what this stands for, this is Builder First Class or Chief Builder. and it's a skill building thing used in the Seabees from the Navy. So go ahead and get one of these. We'll go through it a little bit more with some other subjects. We'll see you on the next video.